Hello students, I hope you all doing well, excellent, and you will having all good health. So in last video we have talked about the introduction of electricity and the charge. In this video we will continue further. We will talk about the electric circuit, electric potential difference, Ohm's law. So let's start. So we'll start electric circuit. So student, I hope you have heard the word electric circuit. And electric circuit means a closed continuous path. Electric circuit means a closed continuous path in which charges move to form electricity. So an electric circuit means, suppose that we have a lamp connected with the plus minus. So suppose that here is a switch. Suppose that this is a switch, and this is when we turn on the switch, what actually happens? The light starts glowing. Light starts glowing. Because when you switch on the circuit, the charge start moving and passes through this lamp and start glow. So it is a closed continuous path. From a source the electrons moves in a closed circuit, closed continuous path. So this closed continuous path on which charge moves is called a circuit. It's called a circuit. Okay, now we have used some symbols, so we will talk about the electrical symbols which will help us to understand. So we will talk about electric symbols, like we have electric cell. Electric cell is denoted with two lines, one larger, other smaller. So the larger segment of the line represent the positive terminal and the smaller segment of the line represent negative terminal. And if we continuously connect some cells, they form a battery. Combination of cells form a battery. For a lamp or the bulb, it's a symbol for bulb. Symbol of resistance. Symbol of resistance. Symbol of variable resistance or rheostat. This is a symbol of variable resistance or rheostat. This is a symbol for wire junction. This is the symbol passing of wire without touching. Passing of a wire, another wire over a wire without touching. Symbol of ammeter. Ammeter is a device used to measure the electricity. Symbol of voltmeter, used to measure potential. Symbol of voltmeter. This is symbol of open key, or you can say off switch. Open key or off switch. This is closed key. Closed key or on switch. On switch. So these are some of the symbols which is used in electricity at the level of 10th class, and further also we have one more meter, that is called galvanometer. This is galvanometer. So these are the symbol which we use. So first of all, circuit is a continuous path, closed continuous path in which charge moves, is called a circuit. Closed continuous path, charge moves, is called circuit. Then we have electrical symbols, and in symbols we have electrical cell, a battery, bulb, resistance or resistor, variable resistance or rheostat, wire junction, non-junctioning wire, ammeter, voltmeter, open key, off switch, closed key, on switch, or galvanometer. So these are the symbols we use. Now after that we will talk about potential, electrostatic potential or electric potential. Electric potential. We'll talk about electric potential. We'll talk about electric potential. Electric potential. Electric potential. As we know, we have studied that similar charges repels and opposite charges attracts. So always we have to do some work to move the charges. We have to do some work to move the charges. And if you want to move a charge in the vicinity of another charge, then we have to do some work, because of it is subjected with the force of repulsion and force of attraction. So to overcome that, if you want to move two charges, then we have to do some work. Suppose that there is a charge and you want to move another charge, say this is charge and this is say Q0, and if you want to move this charge from this place to this place or away from this, in both the cases we have to do some work to overcome the repulsion or attraction force. So quantitatively we says okay, the amount of work done per unit charge in moving it from moving it from one point to another in the vicinity of a charge, or in very simple language, if I tell you, suppose that we have a conductor and if charge is lying here, why will it move to this place by itself? No. But when you connect this conductor with some source, some potential source, then after getting connect with the potential source help the charge to move. The potential source the charge will push this charge and this will move. So this battery is working. This battery is working in moving this charge from this place to this point. So it is denoted with the letter V, and V is given by work done per unit charge. The work done per unit charge. If 1 joule of work is done for moving 1 coulomb charge from one point to another, say this is 1 coulomb of charge and 1 joule is work is done to moving from this point to this point. In this case, we applied 1 volt of potential. This is the SI unit of volt. SI unit of volt. When work is 1 joule and charge is 1 coulomb. For example, I just illustrated like this is 1 coulomb charge and you move this point to this point and you have done 1 joule of work. In this case, we have to apply 1 volt of charge, 1 volt of potential, 1 volt of potential. So the SI unit of potential is 1 volt. Electric potential is a scalar quantity, like electric current, Electrostatic potential is a scalar quantity. It is denoted by letter V. SI unit of potential is volt. It is denoted by letter V. SI unit is volt and potential is a scalar quantity. Like electric current. Now we'll talk about potential difference. Potential difference. If a charge is point, say at A, charge Q is point A, and we move it from point B, so that means the potential is higher at this place and lower at this place. That is why charge is moving from higher potential to lower potential. So we will say this potential at this point is A and the potential at this point B is VB. So as per definition, the potential difference at delta V will be the difference of higher potential minus lower potential. So this is your potential difference, or you can say difference between the potential at two different places. So potential difference is the difference of work done per unit charge at two different places, or we can also say that the difference in work done per unit charge at two different points. So delta V is the same. Delta V is like VA minus VB upon Q, or you can say it's like W upon Q, because we done the work from this place to this place, the total work. So it is potential difference. So electric potential, difference, the difference in the potential at two different points or different places. The difference in work done at two different points or places. So we have other like values like kilovolt, megavolt, or millivolt. So if you have 1 millivolt, it's equal to 10 raised to power minus 3 volt. If you have 1 kilovolt, it is equal to 10 raised to power 3 volt. And if you have 1 megavolt, it is 10 raised to power 6 volt. 1 millivolt, 10 raised to power minus 3. 1 kilovolt, 10 raised to power 3. 1 megavolt, 10 raised to power 6. So these are the some unit of volt potential. And potential difference is basically measured with the potential difference is measured by a device called potential meter. Potential difference is measured with a device called voltmeter. And voltmeter is always connected in parallel with circuit. That means, suppose that we want to calculate a resistance and we want to calculate the potential, so we will be connected along this way. It is always connected in parallel. Potential voltmeter is always connected Okay, so I hope potential and potential difference will be clear to you all of students. Now we'll go for the Ohm's law, but before that you need to know that potential difference is responsible for moving of charge. Potential difference is responsible for moving of charge. So now we'll talk about Ohm's law. Ohm's law. Ohm's law. So Ohm's law is the very basic and fundamental law of electricity and it states that when physical conditions kept constant, the potential difference across a conductor is directly proportional to the magnitude of current flowing. So physical condition means the temperature and pressure at constant temperature and pressure, the potential difference is directly proportional to V is directly proportional to I. Say the potential is V, and current I is flowing through these two ends. So according to Ohm's law, at constant temperature and pressure, the potential difference across this conductor is directly proportional to I. So V directly proportional to I. Now we will replace this proportionality constant, and when we remove it, we will have a new constant, that is R. What is R? R is proportionality constant, and R is known as resistance. So this is your Ohm's law at constant temperature and pressure. That means proportionality means if you have 5 volt battery, you will have the current according to the 5 volt. If you apply 10 volt battery, the current will rise according to the 10 volt battery. If you use 12 volt battery, the current will rise accordingly. So if we see the graph for Ohm's law, the graph will be a straight line passing from origin. For example, say this is V1 and this is I1. So this is V2. So this is I2. So you can see you'll get a straight line passing from origin. So any ohmic conductor will follow Ohm's law, will have the proportionality between V and I, will give you a straight line graph. We can take all more points, like it is V3, so we have I3. So this is like V2 and I2. So if you draw the V and I graph for ohmic conductor, it will be a straight line. So this is the Ohm's law. Or if you want to find out the value of R, we can get it like V upon I for resistance. Or we can say this sign R, we will go for it further. So resistance is V by I. If V is equal to 1 volt and I is 1 ampere. In this case, the resistance will be 1 volt upon 1 ampere, and this is like 1 ohm of resistance. So unit of resistance is 1 ohm. This is the symbol of ohm. So the SI unit of resistance is ohm. The SI unit of resistance is ohm. Okay, so the reciprocal of resistance is called conductance. The reciprocal of resistance is called conductance. Conductance is like 1 by R. So if mathematical definition, R is the ratio of, R can be defined as the ratio of V and I, the ratio of V and I, or the property of matter that opposes flow of charge or current is called resistance. So here I gave you the two definitions. I gave you the definition, the ratio of V and I, or the property of matter that opposes flow of current is called resistance. Okay, students, now we'll talk about resistivity. Resistivity is, suppose that we have a conductor whose area of cross section is also 1 meter and length is also 1 meter. Suppose that we have a conductor whose area of cross section is also 1 meter and whose length is also 1 meter. So the resistivity, the resistance of a conductor whose length is 1 meter and area of cross section is also 1 meter square is called resistivity or specific resistance. That means resistance of a special conductor. So resistivity is given by rho, and it is equal to Resistivity is like R into A upon L. R into A upon L. Actually, I'd like to add one more thing, the factor on which resistance depend. Okay, I'll just complete it and then I'll just add one more thing which will help you understand. Suppose that if A is 1 meter square and length is 1 meter, then the unit of resistivity is unit, and it is like R. So it is the special case of resistance when the length is 1 meter and area of cross section is 1 meter, and if you want to find out the unit, it will be like 1 meter square upon 1 meter. So meter cancel out. The SI unit of resistivity will be ohm meter. Ohm meter. The SI unit of resistivity is ohm meter. The SI unit of resistivity is ohm meter. It is specific resistor or resistance or resistivity. It is the resistance of a conductor whose length is 1 meter and area of cross section is 1 meter. Okay, students, one thing which I need to tell, okay, the factor on which resistance depends. The factors on which resistance depend. Factors on which resistance depend. So number one is length. Resistance is directly depends on length of conductor. Length of conductor. So R is directly proportional to L. Secondly, resistance inversely depends on area of cross section. Area of cross section A. So that means R is inversely depends on A. Combining these two, from 1 and 2, R is L upon A. So now removing this proportionality sign, so R is equal to rho L by A. So if L is 1 and A is 1 meter square, then R is equal to A. So it is the special resistance or specific resistance of a conductor whose length is 1 meter and area of cross section is, right? Resistance also depends. Resistance also depend nature of material, pressure and temperature. Resistance also depends on nature of material, pressure and temperature, that is physical conditions. So student, I hope that the idea of potential difference, Ohm's law, resistance and resistivity will be clear. Resistance and resistivity will be clear. And here I defined the resistivity. Here we got the resistivity. It is rho is proportionality constant or is called resistivity or specific resistance. So by using this formula we can derive the resistivity. It is equal to, this resistivity is the length whose 1 meter and area of cross section is from this. And reciprocal of resistivity is called conductivity. So you can just say that conductivity is like taking another symbol, say beta is like rho, and its SI unit will be mho meter, reciprocal. So hope the idea of potential difference, resistance, Ohm's law and resistivity will be clear. So students, keep studying, work hard and stay healthy and happy. Take care. If you like this video, please share, like, and please subscribe, so that, and please press the bell icon so that when I upload next video you will get the notification, and rest of the part, that is the combination of resistance, heating effect, we'll do in the next video. Bye bye. Take care.